Hi everyone, I hope your weekend is going well. So in this video, we will review some of the material from last week. So we'll talk about memory and metamemory. So specifically today, we'll go over the modal model. We'll talk about metacognition and forgetting and how that plays a part in memory. And then we'll talk about the second model we reviewed in lecture, the working memory model, and finish up on talking about how memory might be constructive. Okay, so first let's talk about the modal model. It's probably a good idea to pause here and try and fill out this description of the model on your own. Remember, we said generating answers leads to better memory later on. So take a second to try and fill out the blanks in this model of memory. Okay, so good work filling that out. So now we can go through the different steps of the model. So we have some input coming in from the left, and we say that input enters our sensory registers, of which we have a few different types. So we have different kinds of registers for different kinds of input that enter our system. So first we might have this visual register, sometimes known as the iconic store, and we said it has a duration of generally less than 1 second or so fairly short. We also have our auditory sensory register, also known as the echoic store, and that has a slightly longer duration, perhaps a few seconds. We might also have something like a haptic store, so a store for memory of feeling or touch. And then we said that our next component is short-term memory, or sometimes called working memory now more often. And we have all these various control processes that could take place in short-term memory. So we can engage in any of these processes, which might make things more likely to enter long-term memory, like rehearsal or verbal coding, and decision-making strategies, as well as retrieval strategies, how to get something from long-term memory. We also said that attention controls what information enters short-term memory from our sensory registers. So attention here is the process of selecting a subset of information and processing that subset. And it seems like attended information is much more likely to enter short-term memory than information that's unattended. And finally, we have this long-term memory store. We think of this as a much more larger and more permanent storage place. And it's important here that there are two-way arrows, so that not only can we consolidate things from short-term memory to long-term memory through processes like rehearsal, we can also retrieve things from long-term memory. So you can think about events from the past, maybe your 13th birthday or something like that, and bring that into short-term memory to be consciously currently thinking about that. So there's a two-way arrow there to indicate that we can both store memories in long-term in our long-term memory storage and also retrieve memories from our long-term memory. So how exactly do things enter long-term memory from our short-term memory? Well, we talked about this idea of rehearsal, and specifically the distinction between two different types of rehearsal. So we define maintenance rehearsal as simply focusing on the to-be-remembered information without little thought about how they're related to each other. So it's sort of this mechanical process of repeating things over and over. So if you saw that list of words that we did in class, you might say table, chair, sofa, without really putting any further imagery with it, just saying the words, repeating them in a very mechanical process. And in contrast, there's also elaborative rehearsal. So this is thinking about what the to-be-remembered items mean and how they're related to each other, and other things you may know as well. And what we find is that elaborative rehearsal is vastly superior for establishing information in long-term memory. So we can look at a little experiment. So we also talked in lecture about the spacing effect and how that might help consolidate information into long-term memory. So if you remember, we made this distinction between massed and spaced practice. So massed practice would be doing all your studying the night before an exam, and spaced practice would be doing a little bit of studying in the weeks leading up to an exam. So having spaces in between your study sessions. And what we find is that in spaced practice, it leads to much longer retention of information. So while spaced and massed practice might produce the same performance on the exam, for example, a week after the exam, participants will remember much more of the information if they had practiced in a spaced manner rather than in a massed manner. And importantly, we also often use meta-memory and metacognition when rehearsing. So what actually are meta-memory and metacognition? So we define metacognition as skills in monitoring and controlling one's own cognitive processes. And we can also talk more specifically about meta-memory. So that's people's knowledge about and awareness of and control over their own memorial processes or their own memory ability. So you can think that for students specifically, this might be a crucial skill for knowing what they do know and what they don't know for an upcoming exam, and forecasting their own learning and their own memory performance. Meta-memory might also include beliefs about memory, so what you think might be effective strategies for making sure you remember something, and also includes the ability to control your own studying, for example. Right, so metacognition is your ability to think about and control your own process of thought, and meta-memory is just a little bit more specifics, reflecting on specifically our own memory processes. We also talked about mnemonic devices. So mnemonics are techniques to improve memory performance, and they generally add some means of organizing the to-be-remembered material in some meaningful way. So we can talk about the method of loci, which has been used by various memory experts. So using this method, you have this sort of memory palace, this mental image of a place that you're familiar with. And you place to-be memorized objects around that memory palace. So this mnemonic device relies on the spatial relationships to establish order and recollect memorial content. So you might visualize yourself walking around an area with distinctive landmarks that you know well, and then link those landmarks to various items that you need to remember. So for example, there's an interesting book written by the author Joshua Foer, who was a reporter that went to report on the World Memory Championships. And by learning this technique, the first World Memory Championships he was reporting on, and a year later he was competing in those World Memory Championships. And a year after that, he actually won them by using this exact method. So this is clearly an effective way of remembering information. If you're interested in that, I'm happy to talk more about it in office hours or through email. We can also use acronyms to help us remember information. So like something like UCLA is an acronym for our school. Acrostics, those are poems or other forms of writing in which the first letters of each line spell out a word. So if you write your name, for example, vertically and then add sentences for each of the letters in your name, that might help you remember those sentences better. And then a keyword system, and this is just forming mental images around keywords, perhaps in a poem content. Okay, so we can also talk about forgetting as a key part of the memory system. And the debate here is whether forgetting is a failure to actually acquire a memory, or rather an inability to retrieve a memory from long-term memory. So whether it's in there and you just can't access it, or whether it never actually reached long-term memory. So we can look at these different serial position curves to examine forgetting under different conditions. And if you remember correctly, what's going on in the beginning of those input positions is called the primacy effect. So those words at the beginning of the list are recalled much better than those words in the middle of the list. And in addition, those words at the end of the list are recalled better than those words in the middle of the list too. And that's what we call the recency effect. And what we said is that the recency and primacy effect are dependent on two different types of memory. So the primacy effect, so those words at the beginning of the list that are recalled better, is dependent upon long-term memory. So because you've had more time to rehearse those items, they're more likely to have entered your long-term memory. And when recalling those items, you're actually accessing that information from your long-term memory. However, your short-term memory, the recency effect, those words at the end of the list that are recalled better, are dependent upon your working memory ability. So those are actually currently still in your working memory, and that's why you remember those better than any of those words in the middle of the list. And interestingly, you can see here the red bar sort of indicates our general idea of the serial position curve, and then the purple and blue bars each have a different manipulation in order to examine something. So if you look here at the 30-second unfilled delay, that would be the purple bar. It seems like that's pretty similar to the standard serial position curve. So it has both the primacy and recency effects. So this is after the task, after you've shown participants the words, you have them sit there for 30 seconds without doing anything and then recall the words. And it seems like they can do just as well as with that immediate recall. However, in the 30-second fill delay condition, so this is like you present them with the words that they need to remember, and then you give them a task for 30 seconds, like counting backwards from 303 by threes. And what you find is that while the primacy effect is still intact, that recency effect is eliminated in this 30-second fill delay condition. So the idea here is that the 30-second unfilled delay, that purple bar, you're still able to rehearse that information that's in your short-term or working memory, and thus that recency effect still exists. But in that 30-second fill delay, your short-term or working memory is now taken up by that computation you might be doing, like counting backwards, and thus that recency effect, which is dependent upon your working memory and keeping those items in working memory, disappears when you fill it with something else. So it doesn't seem like it's just the passage of time because they're both 30-second delays. What does seem to be happening is that information seems to be pushing other information out of your working memory. So perhaps forgetting is more attributed to that rather than just a decay over time. Okay, so it seems like memory for that most recent information would be affected the same by the filled and unfilled delays if the traces were just to decay at the same rate. When we talk about memory decay, we're saying information is forgotten because of gradual disappearance rather than the displacement of memory traces. But as we saw in that prior experiment, it seems like this is probably not the case. It seems rather that something is pushing those memory traces out. In that specific experiment, it might be that task, that counting backwards task, pushing out memory for those words at the end of the experiment, which is why that recency effect disappears. So it's more likely that forgetting is due to interference. So this is the idea that forgetting occurs because recall of certain words interferes with recall of other words, or interference from some intervening digit task like we described previously. So this is not because any of the memory traces are actually missing, but rather they're being confused with other information. So recalling some piece of information is interfering with the recall of other information. So the passage of time in this case is correlated with forgetting, but it's not the cause of it. You remember in the 30-second unfilled and filled delays, the passage of time is not the cause of the forgetting because forgetting happens in one case but not the other, but it is correlated with the forgetting. Instead, the passage of time simply creates opportunities for new learning, and it's the new learning that disrupts memories that are older, not just the passage of time. And importantly, the number of intervening events seems to cause forgetting as well. So we talked about two different types of interference. So the first is proactive interference. So that's when old information interferes with memory for new information. So it's, for example, information from your midterm that you studied for your midterm messing with information that you've studied for the final, for example. And we also talked about retroactive interference. So this is new information interfering with memory for old information. So perhaps information from the lecture right before the final getting confused with information from right after the midterm. So information from a closer point in time interfering with information from farther back. So we can see here in this graph an example of proactive interference. So here's a study where the number of words recalled is compared across different lists. So perhaps you have a list that contains types of trees or types of plants. And with each successive list, participants' recall seems to be going down. And that's because as you move across the lists, it's not like your memory capacity is diminishing, it should stay the same, but rather you get confused whether a word is from the current list or the previous list. So this would be old information, so information from list 1 after you've studied list 2, that's messing with your memory for list 2. So in this case, we'd call that proactive interference. However, if you see that white bar there, what we can do is find, in some cases, this release from proactive interference. If the lists are totally distinct, so maybe lists 1 and 2 are, and 3 are types of plants, and then if list 4 is, the names of different sodas or soft drinks, the lists are not confusable anymore. And your memory ability might go back to its initial capacity because you're no longer confusing items from list 4 with any of the previous items because those items are so distinct and they're from different categories. So when releasing from proactive interference, it increases as the similarity between different categories decreases. So this release from proactive interference will be greater if those categories are more distinct from list to list. Okay, so we can also talk about Badley and Hitch's working memory model, which came shortly after the modal model was developed. And admittedly, the distinctions between these two models are subtle, and this working memory model shares a lot of features with the modal model. So here we have these different components, and in this model, we've replaced the concept of a unitary short-term store with a multi-component working memory system. So if you remember back to our representation of the modal model, we had that visual store, the auditory store, and the haptic store all under those sensory registers. Here, we've separated those out. So we have now the visual spatial sketchpad, which represents maintenance and manipulation of visual and spatial information, so what things are and where things are. And we also have this phonological loop, which maintains and allows us to manipulate auditory information. So this phonological loop and visual spatial sketchpad contain part of that iconic and echoic representation from the modal model, as well as some of those short-term memory processes that were included in the modal model. Here we think the phonological loop, the idea is that perhaps representations here last longer than echoic representations would do so in our sensory register in the modal model. And indeed, the same goes for the visual spatial sketchpad with regards to visual and spatial information. We also have this idea of the episodic buffer that seems to integrate different kinds of information and help consolidate to long-term memory. And then we can also think of the central executive, which is a separate unit that has to do with what we pay attention to, what our goals are, making decisions, and what we recall from long-term memory and send to long-term memory. So we think that both systems, so the visual spatial sketchpad and phonological loop, can hold information for around 20 to 30 seconds. So this is longer than we said our representations were stored in the sensory registers from the modal model. So how do we know that there are actually these two separate stores for auditory and visual information? Well, what we can do is look at the performance of stroke patients on various tasks. And what we have here is a double dissociation. So you can see that on the auditory task, patient PV, who has a specific brain lesion, is impaired on that auditory task, but unimpaired on the visual spatial task. And for patient ELD, he's impaired on the visual spatial task, but not impaired on the auditory task. So this represents what we call a double dissociation, and it shows that we have separate stores for visual and auditory information because you can be impaired on one and not impaired on the other one. So we can define double dissociation as a powerful way to tease apart independent cognitive processes where brain lesion A being impaired, brain structure A impaired, impairs cognitive function X and not cognitive function Y, and brain lesion to structure B impairs cognitive function in Y, but not cognitive function X. So you can think back, this might be like the what and where pathway where we can harm one or lesion one, but not the other. Or the patient, and the patient who could post a letter and the other patient who couldn't grasp objects properly. So this shows us that short-term memory is not just one memory bucket, but it's just like the sensory register where it's split up into these multiple components, perhaps. So finally, let's talk about how memory might be constructive. So we find that prior experience affects how we recall things and what we actually recall from memory. So this is the idea that we sort of take whatever comes to mind, whatever memory comes to mind, and fill in the gaps of information that might be missing. So an example of construction, we can look at autobiographical memory and flashbulb memories. So autobiographical memory is a memory of an individual's history, and what we find that it's constructive. So we seem to fill in these gaps of missing information, and it's also subject to distortion. So they're not always accurate and seem to be able to change with the passage of time. And the way we can study these autobiographical memories are through daily diaries and recall of past events. So we can look at specific autobiographical memories called. So let's talk more in depth about these flashbulb memories. So flashbulb memories are memories of extraordinary clarity, typically for highly emotional events that seem to be retained despite the passage of a lot of time. And what we find is that people are very confident in these flashbulb memories because the events feel very real to them, but they can still contain some substantial errors. So you might be able to think of some flashbulb memories that you have, perhaps when you heard that of the 9/11 attacks or when Michael Jackson died. People have very strong memory traces for these kinds of events. So one study was done, for example, where people were interviewed after the 9/11 attacks, and they were asked how did they hear first about the attacks, who brought them the news, what were they doing at the time, and after a year they were re-interviewed, and around a third of people provided substantially different stories just a year after the attacks. And importantly, they were strongly confident about it too. And after about 3 years, almost half of participants gave completely different accounts of those questions of where they were and who they heard about the attacks from. But importantly, from the view of the person, there doesn't seem to be any difference in accurate and inaccurate flashbulb memories. We seem to be highly confident even when our flashbulb memories may be wrong. And if you're interested in more false memory stuff, there's an interesting TED Talk by Elizabeth Loftus. I think we discussed it in lecture as well. And then another interesting story, Picking Cotton, that shows you a story of a mistaken eyewitness and what happened to someone who was put in jail wrongly. And then there's also an interesting 60 Minutes report on someone that has highly superior autobiographical memory. So really highly detailed autobiographical memory. Okay, so that's all the information that I have for you guys. Thanks for watching this video today. Again, if you have questions, feel free to come to my office hours on Monday. I'm also holding an extra office hours on Thursday between 2 and 3 p.m. And as always, you can email me and I'm happy to clear anything up. All right, thanks guys. See you next time.